If you've traveled across India recently, you've likely noticed a distinct shift in how the country moves on rails. We are living squarely in the era of the Vande Bharat Express. Right now, 81 pairs of these semi-high-speed train services are active across the country, connecting major economic hubs with a new standard of efficiency. But this flagship fleet operates against a hard technological ceiling, a design speed of 180 kilometers per hour. Reaching 180 was a significant achievement for the national network. Yet, as domestic supply chains expand and the global economy accelerates, India requires transit systems that can move people and resources significantly faster. The Vande Bharat network provides the baseline for the upcoming transition into the next-gen era. In March 2026, the Railway Board issued a directive to the Integral Coach Factory, officially approving the coach production program for 2027 and 2028. This chart shows the jump from the current 180 km per hour limit to a new 220 threshold. But there's a difference between design and daily routes. They operate at a maximum of 200 kilometers per hour, with that top 20 acting as a safety buffer. To move at those speeds, the physical trains will be massive. The plan requires broad-gauge rakes made up of 16 coaches each. Pushing a 16-coach rake to 220 kilometers per hour generates intense aerodynamic and structural stress. To handle this, the coaches will be constructed with full steel bodies. By upgrading both the structural integrity and the top speeds, Indian Railways is officially transitioning from semi-high-speed transit into true high-speed rail. Moving from a directive on paper to actual steel on the tracks requires an immense industrial footprint. To execute the heavy engineering, the ICF awarded the contract to BEML, tasking them with designing, manufacturing, and commissioning these initial high-speed sets. This pie chart shows the total commitment of 866.87 crore rupees. That figure covers the initial design phase, the physical tooling, one-time development, and the highly specialized testing facilities required. When you isolate the manufacturing portion, each individual train car costs 27.86 crore rupees. That per unit cost includes all of the non-recurring charges. Building entirely new engineering jigs and testing environments requires significant initial capital. This capital investment secures the foundational engineering knowledge required to scale high-speed transit domestically. This new expertise will feed into a broader ecosystem that already includes operational giants like the Rail Coach Factory in Kapurthala and the Modern Coach Factory in Raebareli. These factories already handle a diverse portfolio, producing everything from the Namo Bharat and Amrit Bharat networks to standard regional metro rakes. Executing the 220 km per hour project elevates these domestic facilities. They are evolving from producers of standard rolling stock into high-speed rail developers. The production timeline is set. By the 2027-2028 rollout window, these new 16-coach steel rakes are scheduled to hit the tracks. By engineering the leap to 220 internally, India is manufacturing its own path to becoming a global rail superpower.